The problem is multi-stage graph. This problem can be solved by applying dynamic programming strategy. In this video, I will explain you what is the graph problem. Second thing, how dynamic programming is applicable. Third thing, I will solve it using forward method. Let us start. Let us talk about the graph. A multi-stage graph is a directed weighted graph, and the vertices are divided into stages such that the edges are connecting vertices from one stage to next stage only. First stage and the last stage will have just single vertex to represent the starting point, that is source or ending point or sink of a graph. This is usually useful for representing resource allocation. So here there are various paths from source to sink. I have to select the path which is giving me minimum cost. This is the objective of a problem. So it's a minimization problem, that is optimization problem. The problem can be solved using dynamic programming. Let us understand whether the dynamic programming can be applied on this one or not. So dynamic programming works on principle of optimality. Principle of optimality says that a problem must be solved in sequence of decisions. Let us see, can we solve this by taking sequence of decision. If I start from here, from first stage, that is stage 2 here, okay, in this stage I have to select one of the vertex. If I select 5, then I should make sure that what I am selecting is optimal, going to give me optimal result. Okay, once I selected this, now again I have two options here. From 5 I can go to 8 and 7. Out of this, again I have to decide and select any one. Again next I have to decide and select any one. So every stage I can take a decision. So yes, here the principle of optimality holds. Now I'm applying dynamic programming procedure, that is tabulation method, to get the data filled in the table. For each vertex I am going to find the cost, and for finding the cost I'll start from here. Because if you see from here, the edges are going that side. So if I want to find the cost of this one, then I should consider all the edges reaching till sink. If I find the cost of 3, then I should consider all the paths going till sink. If I consider 10, then the cost of path reaching there. Now if I say sink, then the cost is 0 obviously. So for the last vertex, the cost is 0. And the vertex is 12 only. For the last vertex, how I got the cost as 0, I will write down like this. Cost of fifth stage vertex 12. So I will write here stage number and here the vertex number. And the cost is 0. This is how I will use the formula. Cost of 5, 12 means fifth stage and the vertex number 12. And the cost is 0. Let us find out the cost of all these vertices in this fourth stage. So first, cost of stage 4 vertex 9. So what is the cost of reaching till sink? It is 4. This edge 4, just a single edge path it is. So it is 4. And the cost of fourth stage 10th vertex, it is 2. Cost of fourth stage 11th vertex, this is 5. Vertices 4 to 5, right? So from reverse 5 to 4. So this is 5, this is 2 and this is 4. Now by taking these vertices 9, 10 and 11, where I am reaching? I am reaching on 12th vertex only. So this is 12 and 12 and 12. Explain you what does it mean by D here. Okay, very soon. Now let us take third stage. So I have the vertices 6, 7 and 8. I will find out the cost of these three. So first 6, cost of third stage 6th vertex. Now from here if I see, there are two edges coming out. So this is 6 to 9 as well as 6 to 10. So which one I should select? I should select the minimum cost. So let us consider both, then select the minimum. So I have to select minimum of what? Cost of an edge 6, 9 plus cost of fourth stage 9th vertex, and also cost of an edge 6, 10 plus cost of fourth stage, 10th vertex. I have to take the minimum of these two. So what is that? 6 plus cost of 9, 5 plus cost of 10. So 6 is what? This 6 to 9 is an edge. I am writing it like this, right? C is cost of an edge. Cost is cost of an vertex. This is C is weight of an edge. Okay, I am writing it as weight of an edge. 6 plus 9. So what is this equal to? Minimum of C 6 to 9 is how much? 6 plus cost of 4 comma 9 is here 4 comma C of 6 comma 10 is how much? 5 comma plus cost of 4 comma 10 is this one 2. So out of this, which one is smaller? This one is smaller. The vertex 10 has given me smaller value. 10 has given me smaller value. What is that? 7. So 6 is 7. And which vertex has given me minimum cost? Vertex 10. So the one which is giving minimum result, we have to write on that one here. Cost of 7th vertex, that is stage 3. Here cost of 3 comma 7. From 7 vertex, if you see, there are 2 edges going out. So to know the cost of 7, I should know the cost of 9 and 10 plus the cost of this edge. So 4 plus cost of 9, 3 plus cost of 10. Out of those two, whichever is minimum, I should take that one. So I'll write like this. Cost of an edge from 7 to 9 plus cost of a vertex 9 in 4th stage, comma, cost of an edge from 7 to 10 plus cost of a vertex 10 in stage 4. Out of these two, I should take minimum. Now, if I take minimum out of these, cost of 7 to 9, edge 7 to 9 is 4 plus cost of 9th vertex is there from the table. So you can see how the values from the table are useful. So this 9 already we found out, now it is useful. It was useful for 6 also, now for 7 also this value of 9 is useful. So this is what overlapping subproblems are there in dynamic programming. So 4 comma C of 7 to 10, 7 to 10 is 3 plus cost of 10. Cost of 10 is how much? 2. Out of these two, this is minimum, that is 5. So cost of a vertex 7 is 5. This we are getting due to which vertex? 10. So in D, I should write down 10. So in D, I should write down the vertex which has given me the shortest path, the minimum cost. Next is cost of 8. So there are 2 edges going out from 8 to 10 and 11. So cost of an edge from 8 to 10 and the cost of vertex 10 in 4th stage, comma, there is no space, I write here, C of 8 to 11 plus cost of a vertex 11 in stage 4. I have to take minimum of these. So this is minimum. I know these values, so I will replace them. Cost of 8 to 10, 5 plus cost of an edge 10, vertex 10, 2. Comma, cost of an edge 8 to 11, 6 plus cost of a vertex 11 is 5. Minimum is 7. Who has given this 7? Vertex 10 has given this 7. So here it is 7 and the vertex that has given that result is 10 only. Now let us find the cost of all those vertices which are in stage 2. Cost of vertex 2 in stage 2. See, there are 3 edges going out from here. 1 for 6, 1 for 7 and 1 for 8. So this is minimum of cost of an edge from 2 to 6 plus cost of vertex 6 in stage 3, comma, cost of an edge from 2 to 7 plus cost of a vertex 7 in stage 3, comma, cost of an edge from 2 to 8 plus cost of a vertex 8 in stage 3. First we are writing stage, okay. So I have elaborated the cost function here itself. So out of these I have to take the minimum. See, this one is how much? Cost of an edge 2 to 6. 2 to 6 is 4 plus cost of 6 is 7, comma, cost of an h2 comma 7 is how much? 2 plus cost of this 7 is 5 comma, c of this one is 1 plus cost of a vertex 8 is 7. Out of these three, which one is smaller? This is 7 and this is 8 and this is 11. So 7 is smaller. So this one has given us minimum result. So the answer of this cost of vertex 2 is 7. And who has given us minimum result? The vertex 7 has given us minimum result. So this is 7. Cost of second stage fourth vertex is minimum of, from 4 there is only one edge, so cost of 4 comma 8 plus cost of vertex 8 in stage 3, out of this there is only one value, so this is 11 plus cost of 8. 11 plus cost of 8 is 7. So this is 18. Who gave the answer? 8 has given the answer. This vertex has given the answer. So this is 18 and this is 8. Cost of second stage fifth vertex is minimum of, from 5 there are two edges. One is going to 7 and one is going to 8. So C of 5 comma 7 plus cost of seventh vertex in stage 3 plus comma, cost of an edge from 5 to 8 plus cost of vertex 8 in stage 3. So out of this, minimum of C of 5 comma 7 is 11 plus cost of 7 is 5 comma, this one is 8 plus cost of 8 is 7. So this is 16 and this is 15. 15 is smaller, and who has given this result? 8. So this is 15 and this is 8. Now almost the table is filled here, only one value is remaining. Now we are at the stage to find the minimum cost for this, that is starting vertex. So that will give us the minimum cost from here to there, source to sink. Cost of 1 comma 1. From vertex 1 in stage 1, that is first stage, then vertex, there are 4, 1 to 2 and 3 and 4 and 5. So I should consider all and take the minimum. Do I have the cost of vertex 2, 3, 4, 5? Yes, already they are filled here. So that is easy for solving. Now to find this cost, see, this is cost of an edge from 1 to 2 plus cost of 2 to 2, comma, cost of an edge from 1 to 3 plus cost of third vertex in stage 2. What is minimum? Let us find out. See, the values are 9, 7, 3, 2, right? So this is 9 plus cost of 2 comma 2 is 7, comma, cost of 1 comma 3 is how much? 7 plus cost of vertex 3 is 9, comma, cost of this vertex 1 comma 4 h is how much? 3 plus cost of 4 is 18, comma, cost of 1 comma 5 is 2 plus cost of 5 is 15. Out of this, which one is smaller? This is 16, this is also 16, this is 21 and this is 17. So I got two answers that are same. So the answer is 16 only, but that is going via what? First was vertex 2 and second was vertex 3. Both are giving same result, so I'll write 2 or 3 here. I can take only one also, but I am writing both to see how the difference will be. Just like first filling the smaller values, then getting the answer for the larger value. So we started from the backwards side, that is from the back side of our multi-stage graph. Last stage onwards we started. But still this is called as forward method. How? We will see that next. Let us frame the formula now. I did not show you the formula, but the procedure already I have shown you. Let me frame the formula. We were finding it like this. Cost of ith stage jth vertex. This I is a stage number, right? And this j is a vertex number. So this was minimum of, I was taking minimum of what? This was cost of an edge from vertex J to some vertex L plus cost of that next vertex L. If I say J and L, J is supposed 2, then L is supposed 6. So J cost of 2 to 6. Then the cost of 6, third stage 6 vertex. So we were writing the stage number here, I plus 1 and L. This was the formula we were finding. Whatever the edges are available, for 2 there are 3 edges. So we wrote the same thing 3 times. You can see that for finding cost of second stage third vertex was minimum of, one of the value I will write down, third vertex to sixth vertex plus cost of third stage sixth vertex. If I say this is stage number 2 and vertex, this is J, then minimum of cost of an edge J to some L, some vertex L, then cost of that L, and that L6 is definitely in the next stage. So this is I plus 1. If I is a 2, then this is 2 plus 1. So this is I plus 1. This is how we were using the formula for finding these costs in multi-stage graph. So this is the formula for multi-stage graph. And we say that J and L belongs to set of edges and L belongs to next stage. So this is the formula that you can find in the textbooks. Now the actual dynamic programming starts, right? Already we have the formula and filled up the table based on the dynamic programming approach to get the result. Actually, the method of dynamic programming is to solve a problem by taking sequence of decisions. We have not taken any decision so far, but now we are going to take the sequence of decision based on the data available. So already I was writing the D value, whichever the vertex was giving us minimum result, I was writing the D value there. Using that we take a decision. What decisions we take? From here where we should go, to which vertex, then from there where we should go, then from there where. So decisions are taken only you have this complete data with you. So already we have the data. Now we are going to solve it by taking sequence of decision, and we will start from vertex 1 onwards towards sink. So this is forward. The decisions will be taking in forward direction. So the based on decisions, this is forward method. Let me do that. First of all, distance of D values I have for 1, 2, 3, 4, all I have. So first I will write stage number. This is a stage number, right? And then I will write on vertex. This is vertex. D of 1 comma 1. So actually we are concerned about this. I am writing it like a formula. Okay. So this is stage number and this is vertex number. So we will consider this vertex number. What is the answer? 2. So let us take 2. Now in the second stage already we have taken 2. D of 2 comma 2. See, this was the first stage. We selected first vertex. In second stage, second vertex, vertex 2. Now from there where we should go. So 2, who has given the minimum result for 2? 7. So this is 7. In D we have 7. Now we are on the 7th vertex in stage 3. Now being on stage 3, where we should go next? On 9 or 10? Which one? So 7 has given us 10. So 10. Now we are on the vertex 10 in stage 4. Then from 4th stage 10th vertex, where we should go next? So table will tell us everything. So we should go on 12. So that's it, 12. So our path is what? We started from vertex 1 to 2, then 7, then 10 and 12. So this 1 to 2, 2 to 7, 7 to 10, 10 to 12. This is the shortest path from source to sink. That this D values has given us the result. So now we have taken sequence of decisions. Let me show you once more for 3. I said that for both 2 and 3 we got the answer as 16. So let us 3, what does it give? I start from vertex 1, that is stage 1. So 1, 1 gives us what? 3. Then I am on the stage 2 on vertex 3. Then third vertex. What is the one which has given minimum result? 6. So this says goes to 6. Then in the third stage, I am on vertex 6 now. So, okay, I'll do it here also. I have gone to 3, then 3 has sent me to 6. Now being on third stage, 6th vertex, where I should go next? So 6, what's the answer? 10. So go to 10. So it says that I should move to this one. So this is the decision I have taken. Then 10 is in 4th stage. So from 10th vertex where I should go, 10th vertex, we already have seen this answer, that is 12. 12. So from 10 I should go to 12. So this is another route you see. This is another route which is giving us the minimum result. So this is 1, right, via 2, 7, 10, then 1, 3, 6 and 10 and 12. So I have 2 paths of same cost. So the optimal result is only 1, but by chance we are having 2 paths which are giving us the same result. That's all about multi-stage graph problem, and I have explained you how dynamic programming is followed here.